Okay, my dear class, now we move to one of my very favorite topics, which are trig functions on the unit circle. So we're going to start out by exploring ways that you will be able to find the value of any of the 6 trig functions if you have a point on the coordinate plane. Okay, so it says let theta be any angle in standard position, meaning you're going to start at that positive x-axis, and point P with coordinates x, y be a point on the terminal side of theta. Let R represent the non-zero distance from P to the origin. It sounds very complicated here. It really is not. I think the best thing for me to do is just to go straight to the examples. So let's take a look at example 1, which is when you have to evaluate trig functions given any point. So the first example here is asking you to find, it says the given point lies on the terminal side of an angle theta in standard position. Find the values of the 6 trig functions of theta. So to demonstrate this, I am going to draw that point or approximate. So we are talking about something like this: 1, 2, 3, 4 for x, 1, 2, 3 for y. So if that is my point, what would be the angle if that's my terminal side? So I would start over here and I could go that way. So that angle, the angle we're going to be talking about, will always be the angle formed with the x-axis, this one. Not over here. It has to be the one with the x-axis. Okay? All right. Very important to remember because students make mistakes when they draw their angles because of that. It's always with the x-axis. So, if you think of a triangle now, I can 1, 2, 3, 4. I can just go ahead and connect, make a right triangle right here. That's the triangle, right? This is theta. So I'm going to write theta. And I know how long this side is. It has to be 3 units because of this. That's the y. And this side here has to be 4 units. I know that because that is the x value of that point, the x coordinate. So they want you to write the 6 trig functions for that point. So the first thing I need to know is how long this side is. Well, that should be pretty easy. You have a right triangle, so you can use Pythagorean theorem, or this is a very common type of triangle. It's a Pythagorean triple. It's just a 3, 4, 5 triangle. If you don't know that, you can just do x squared equals 4 squared plus 3 squared. But in my case, and probably for several of you, you should already know that this is 5 units long. So now it's pretty easy because I have my angle. I know that's going to be the opposite side. This is going to be the adjacent side, and that's the hypotenuse. So I can do sine theta, cosine theta, tangent theta. And then the reciprocal functions, which are going to be cosecant theta, secant theta, and cotangent theta. And now it's just a matter of filling in those values. So sine theta, I know that sine is opposite over hypotenuse. So here it's 3 over 5. Cosine is adjacent over hypotenuse. So 4 over 5. And tangent of the angle is going to be opposite over adjacent. So 3 over 4. And then it's just a matter of flipping them. So 5/3, 5/4, and 4/3. Done. Okay. Then 1b, that is the point that was given to me. I am going to just sketch that point. And that point would be -2, 1, 2 to the left, and 1 down. So there we are. So once again, we're talking about that angle with the x-axis. This is going to be, now, there are different ways to do this, but I usually just look at the distance. So I don't take into consideration the size until the end. So this side length here is 2, and this is 1. And then you can just use Pythagorean theorem, and you can easily see this is going to be square root of 2 squared plus 1 squared, which is just square root of 5. All right. So now I am going to write the 6 trig functions: sine theta, cosine theta, and tangent theta. And then cosecant theta, secant theta, and cotangent theta. All right. Okay. Now it should be easy. Just make sure you rationalize. So sine is opposite over hypotenuse. So that would be 1 over square root of 5. But when you rationalize, you get radical 5 over 5. Right? Because think about it. 1 over square root of 5, you have to multiply both by square root of 5. And you get it. This will cancel out square root of 5 over 5. All right. Cosine theta would be 1 over square root of 5. Oh, sorry, never mind. 2 over square root of 5, which would be then 2 square root of 5 over 5. Once again, you got to rationalize. Tangent theta would be opposite over adjacent, so 1/2. Then you flip them. So this one actually would be just radical 5. We can flip from here, right? Because it was that. The other one was 2. This was, for cosine, it was 2 over radical 5. So now it's going to be radical 5 over 2. And cotangent theta is just 2. And that takes care of that. Now, the question is, how about the sines? Well, we're going to talk about this shortcut later. But if you want to know which functions will be positive and which functions will be negative, a lot of teachers teach this using all students to take calculus. So in first quadrant, all trig functions will be positive. In the second quadrant, this is 1, this is 2, this is 3, and this is 4. So first quadrant, all will be positive. Second quadrant, only sine is positive. Third quadrant, only tangent is positive. So anything that is not tangent is going to be negative. Or cotangent, of course, because it's the reciprocal. Now I'm done. Okay. Now, they give this very funny name. They call quadrantal angles. But what we're talking about here is determining the trig values for these angles here, when the angle is on the x-axis, y-axis, x-axis, y-axis, the negative x and negative y. Okay? So to determine that, what I usually do, I think that's the easiest way to do this, is this point right here. If you think of it as, well, you have it right there. Radius 0. This is so here we go. 0, the radius, the negative radius, because it's to the left, 0. And then over here, 0 negative radius. Okay? So if you want to determine cosine of 270, I know we haven't really talked about that, But, oh yeah, they did talk about it here. Yeah. Sine y over, okay, the radius, cosine x over the radius. So I just want you to focus on this. Sine being y, cosine being x, tangent y over x, okay? So if I were to tell you, that the radius here is 1, I don't really want to get ahead of myself, but let's say that the radius is 1. If the radius is 1, this point here would be 1, 0. This point here would be 0, 1. This point here would be negative 1, 0. And then this point over here would be 0, negative 1. So just like we mentioned before, I want you guys to think of the first number, the x, as cosine, and the y as sine. X cosine, cosine, sine, y sine. X is cosine, y is sine, and so forth, okay? So if you think about 270 would be, this would be 180 to 70, right? So what would cosine 270 be? So my question for you is, what is the x coordinate of this point over here? And the answer is 0, right? So cosine of 270 equals 0. Okay? Because that point there would be 0, negative 1. How about pi over 2? What would cosecant of pi over 2 be? Well, cosecant is the reciprocal of 1 over sine. So if you're talking pi over 2, you're saying this, right? So what are the coordinates of this point here? It would be 0, 1, right? So cosecant pi over 2 would be the inverse, the reciprocal of the sine function. So sine pi over 2 is equal to 1, and 1 over 1 is 1. So the answer here would be 1, 0, 1. Okay? Moving on. How about cotangent negative 90? So now negative 90 would be the same as positive 270, right? Because we're going clockwise. So negative 90 would be over here. So for this point here, I would have cotangent would be the reciprocal of tangent, right? So tangent is y over x. So the coordinates of this point over here would be 0, negative 1. So tangent would be of this angle of negative 90 would be negative 1 over x, which is undefined. But I'm not talking about that. I'm talking about cotangent. So cotangent negative 90 would be x over y, which is just 0. Okay? So those are the quadrant angles. Now, how do we evaluate trig functions of any angle? So you're going to have to find a reference angle, and what what we mean by that is the angle in the first quadrant. The equivalent angle in the first quadrant. You need to find the value of the trig function, and then you adjust the quadrant. You adjust the sign according to the quadrant. So this is just what I was telling you before. Over here, quadrant 1, all students, so only sine is positive, take, only tangent is positive, calculus, only cosine is positive. This is the little trick that I told you about. So these are going to be the reference angles that are going to become our best friends. You're going to have to memorize them. Okay? And I find that the easiest way to memorize this is by memorizing sine 30. Sine 30 is 1/2. Memorize that. Okay? If sine 30 is 1/2, then cosine 60 should be 1/2. Cosine 60, because they're complementary angles. You should have learned that in geometry. What's left over is going to be square root of 3/2 or square root of 2/2. And then this one, usually I use the other two to figure out. But sine 30 1/2, cosine 30 is radical 3/2. And then you flip that for the 60. Sine 60 is square root of 3/2. And cosine 60 is 1/2. And the 45-degree angle, or pi/4, is easy because, of course, it's right isosceles triangle. So these two are going to be equal, radical 2/2. So 45-degree angles, we have the square root of 2. For 30 and 60, sine 60 is the same as cosine 60. Cosine 30 is the same as sine 60, sorry. And then you can just, to find tangent, just do y/x. So 1/2 over radical 3 for so. To find the tangent, 1/2 over radical 3/3, sorry, over 2. It will be, okay, let me just fix that real quick. Over 2. Because tangent is sine over cosine, or y/x. So 1/2 over square root of 3/2 gives you 1 over square root of 3, which is radical 3/3. For 45, tangent is just 1, because, of course, this is the same. That's the same. Anything over itself is 1. And for 60, if you do y/x, you get square root of 3/1. Okay? But yeah, become very familiar with this. It's going to come back over and over again. So, on the unit circle, I mentioned before, sine is going to be the y coordinate, cosine is going to be the x coordinate, tangent is y/x. This is very important, my friends. Very, 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 very important. Sine is y, cosine is x. Cosecant is 1/y, so it's the reciprocal, and of course you cannot have a 0 in the denominator. Secant is 1/x, and of course, once again, you cannot have a 0 in the denominator. Tangent is y/x. Once again, x cannot be 0 because they need to be undefined, and cotangent is x/y. Just flip it. Okay? All right. So now here is our good friend, a unit circle. We'll come back over and over and over and over again. Okay? So you have your degree measures in blue. You have your radian measures in red. And here are the coordinates, which means this one here, I'll make it bigger. This is going to be cosine. Oops. This is cosine, and this is sine. Cosine, sorry. cosine, and this one is sine. Okay, x is cosine, y is sine. X is cosine, y is sine. So, will you have this in front of you? No, but you can make your own because you're going to memorize your reference angles, which are, like I said before, first quadrant. These are your reference angles right here. Reference angles, these ones, they are your reference angles. First quadrant. Okay? So, let's look at some examples, as always. Okay, so you need to find these trig values using the unit circle. I'll let you use the unit circle now, but later on, you are going to have to come up with these without anything. So they want cosine pi over 4. Well, pi over 4 is over here, right? So what is cosine pi over 4? Cosine pi over 4 should be the x-coordinate, which is square root of 2 over 2. So the answer here should be simply square root of 2 over 2. Why is it called a unit circle? Because the radius is 1. Then we have to figure out what sine 120 is. So sine 120, I'm going to go back here. 120 degrees is, we should look at the blue one. It's over here because this is 90 plus 30, 120, which is also 2 pi over 3. Which now we can say, what were they asking for? A cosine or sine? Let's see. Let's go back. I forgot. Sine 120. So sine 120 should be the y coordinate, which is right here. Positive radical 3 over 2. Radical 3 over 2. Then they want cotangent to tan. Cotangent to tan. So 2 tan is over here. And remember, tangent is y over x. So cotangent would be x over y. Now they're both negatives. They're going to become positives. So cotangent is x over y. So radical 3 over 2 over 1/2. These cancel out. They're left with radical 3. And then we have secant of 7 pi over 4. So secant 7 pi over 4, when I see this right away in my head, I think, okay, well, 8 pi over 4 is 2 pi, so it's going to be negative pi over 4. So secant is 1 over cosine. So remember, cosine is x. So now I have to do 1 over the x-coordinate of that. So 7 pi over 4. 7 pi over 4 is over here, which is coterminal with negative pi over 4. So if we're doing 1 over radical 2 over 2 would turn out to be, well, if you're not sure, I'll show you that in detail, but it should be just 2 over radical 2, which then you have to rationalize. So 2, 2 over radical 2. And what happens when we rationalize? Times radical 2 times radical 2, you get 2 radical 2 over 2, which is just radical 2. So square root of 2. Some of you may be able to just see that right away, but if you can't, you can just do the long way. Okay, I think that's the last example for this. Yeah. Okay, so that was just an introduction to all the trig that is going to be coming up. We're going to spend some time practicing these. They need to become second nature to you. And see you next time.